Okay, so you're going to notice that with these videos, since I'm on line 18 A3Z, I've had to add different numbers and stuff to them. So it might be easier for you if you're not checking them on YouTube. I do link them as a video response to each other. But I do notice that they don't come up. If you do a Google search on YouTube and stuff, they don't always come up. So the best thing is to go to the SETI index webpage on Blogspot, or go to Skidoo and type in the SETI Wow signal, and it should bring up my indexes there for you. Okay, so this is part 145. It's line 18A, 3Z, 2, and then A. I added A because it's the next step after 2. This is actually the second part of the last video, so these two should be going. You should be watching the two of them together. Okay, so this is Accelerator Graphite Plasma Deuterium Isotope Recycling UFO 5G Wow Seti. Again, when you see the words UFO 5G, it means there's a formula found in the video. Okay? I'm trying to remember to do that for you, just so you know which ones have formulas in them in case you want to take a quick peek. Okay? So this is the Wow Seti alien signal. And my thoughts, February 21st, 2012. I found all sorts of data of new test results in PDF files that can be used for the UFO's engine accelerator plasma formulas. I'll be reading what each finding has, its test results, and the abstracts, giving credit where it's due. I've come up with more formulas for the 5G UFO engine in this line of data. It looks like I've gotten just keywords in the past. Now the actual methods to use are coming up now for all of those formulas that I've been writing. Thank you for publishing your findings. Keep them up to date for me so I can see what you have and compare notes to help develop something new. Okay? So here's a quote to read. Design status and development strategy of China liquid lithium-lead blankets and related material technology. And there's the volume number and stuff there. From 2007 from Wu Y. A series of fusion reactors named FDS series have been designed and assessed in China, with 4 types of liquid lithium-lead blankets, including the RAFM steel-structured, heat-cooled quasi-static LIPB tritium breeder SLL blanket. The RAFM steel-structured HELIPB dual-cooled DLL blanket. The RAMF steel-structured refractory material, thermally insulated, high-temperature LIB-HTL hydrogen production blanket, and the RAFM steel, or optionally the austenitic stainless steel-structured dual-cooled high-level waste transmutation DWT blanket. That was a mouthful. To demonstrate and validate the feasibility of the candidate blankets for fusion energy application, the 3-phases strategy of TBM, test blanket module development, i.e. material R&D and out of pile. Now R&D has come up before, just so you know. I should put that in the tags actually. Experimental mock-up, East TBM and ITER TBM have been proposed. A brief overview of the 4 types of lip blanket designs and their goals are given. Material technology requirement and development strategy are also presented in this paper. From 2007, Elsevier BV, all rights reserved. Okay? And he's on the www.journals.elsevier.com. You can look at his work there. Most of these papers are for sale. If you need them, go and buy them. Influence of particle dispersions on the high temperature strength of ferritic alloys. And there's the volume number, issue 2007 again. And this is from Holzer DT, Bentley J, Sokolov MA, Miller MK, Odette GR, and Ellinger MJ. This is 4 ferritic alloys based on the composition of that. Nominal were developed with a predominant dispersion of either oxide particles or nano-sized that nanoclusters. Tensile specimens machined from the alloys were tested at room temperature and ranging from 360 degrees to 800 degrees Celsius in air using a strain rate of 10-3s-1. The results showed that the high temperature strength of the NC strengthened alloys was significantly better than that of the oxide strengthened alloys. So this is very important. So you want to pay attention to this. The room temperature yield strengths of the two alloys containing the NC were 1469 MPa and 1261 MPa, while the yield strengths of the two oxide dispersion alloys were 819 MPa Y-Ti oxides and 583 MPa Ti oxides. However, the ductility of the oxide strengthened alloys was better than that of the NC strengthened alloys 2007. Okay, so the effects of ELMs on ITER diverter armor materials. There's the volume number, issue 2007, from Ziklukin, Klimov, Landman, Linky, Loart, Marola, Podporov, Federici, Vaslev, Pastanchi, Harari, Menashev, Levashov, Muziko. I probably said all your names wrong, sorry. This paper is concerned with investigation of an erosion of the ITER-like diverter, plasma-facing components under plasma heat loads expected during the Type 1 ELMs in ITER. Again, these came up with the Wow Seti signal, so they are important. They're going to be used in the formulas, okay? These experiments were carried out on Plasma Accelerator QSPA at the SRC RF Trinity under EU RF collaboration. Targets were exposed by series repeated plasma pulses with heat loads in range of 0.5 to 1.5 mg/m squared and pulse duration of 0.5 ms. Erosion of the CFC macro brushes, was determined mainly by sublimation of pan fibers that was less than 2.5 per pulse. The CFC erosion was negligible at the energy density less than 0.5. Okay, and it was increased, there's the different things, per pulse. The pure tungsten macro brushes erosion was small in the energy range. There's the energy range there. The sharp growth of the tungsten erosion and the intense droplet ejection were observed at the energy of 1.5, 2 points. Sorry. www.journals.elsevier.com. Okay, I only read all the stuff on the PDF files because these guys did some testing. They're showing you their theories, and all this stuff is coming up with the signals, so it's going to be used one way or the other, okay? February 21st, 2012, my thoughts. I'm looking at this PDF, quote, effects of ELMs on ITER diverter armor materials, okay? It talks about a plasma accelerator. Now, this is one of the key words here, and all these other new words that I've not come across. We want to accelerate cooled neutrinos that split with leptons' help. So let's look at the influence of particle dispersions on high temperature strength of ferritic alloys. I wonder if the lithium-7 and magnesium-24 would help in this case. Quote, gamma ray of 2.7 MeV followed by a beta decay to form magnesium-24. Source of quote was line 18A3Z. Nuclear reactors, lithium, magnesium, metals, restivity, UFO 5G Wow Seti. Again, that video has what? A formula. Yeah, formulas are good. My thoughts continue. Can we use gamma rays in the sputter laser gun or the turbine invention mentioned earlier? New formula idea. Lithium-7 plus the gamma ray 2.7 MeV followed by a beta decay to form plus magnesium-24 plus liquid argon gas plus electron neutrinos. Yes, I changed the name. Instead of just neutrinos, I actually did one that can take a charge. So protons plus atoms plus split lepton formula, which is leptogenesis, I just figured that one out after the fact, equals 5G force. I'm not sure if I'm supposed to say 5G force, but I'm putting it there. I know it's 5G, but I'm not sure if the word force is proper. If it isn't, let me know. Please. Thank you. Please publish. Please. I'm having trouble. I'm losing my voice. Sorry. Please publish any findings with this experiment so we can see if it works. Next, I see from this article, quote, reducing the recycling of hydrogen isotopes. I was looking at ways to recycle hydrogen to extend the fuel's burning power. Another quote from the article. Deuterium NBI reference discharges. My thoughts. Deuterium was mentioned before in my formulas based on it coming up in the data. Here it is again in these test results. Was slowing down hydrogen recycling, making fuel burn longer? Another quote from this article. Effects on the plasma density and the impurities were obtained by preconditioning the PFCS with ohmic helium discharges and performing the first deuterium NBI discharge as soon as possible after applying the lithium coating Elsevier BV. Just so you know, I'm not sure if that came up in this article. What happened is I did everything in AZ and I had so much data I broke it down into about 5 different modules, so I kind of got my thoughts all scrambled, literally. And I was frantically trying to figure out how to put them together, and I thought I did. I must have missed this one, I'm sorry. This data is going to come up in one of these videos. In the next 5 videos, okay? And they're all together, so you have to watch all of them anyways, right? So another quote from this article. Effects on the plasma density and the impurities were obtained by preconditioning the PFCS with ohmic helium discharges and performing the first deuterium NBI discharge as soon as possible after applying the lithium coating. It's from Elsevier BV. My thoughts. I'm not stealing his information. I'm basically just showing you what he said about different things. When I do the actual blog post, I'll be putting a link to his blog so you can take a look at the rest of the stuff he's written. He's written a lot more than that. All I did was pull out certain quotes and stuff that pertain to the Wow Seti signal, okay? So these are my thoughts. A successful test result that can probably be used in this alien technology we're discussing for a UFO engine component plus new formulas. Thank you all for publishing your findings and helping us in our quest to make a 5G UFO engine. So I'm going to show you the different videos that have come up so far. As of February 22nd, this is how much research I've done so far, just tonight alone. It took me several hours to do this, okay? There is a lot more videos for 18A. There's like 18A4, 18A5. So unfortunately, God, I don't know how many we got. Yeah, we got quite a few for line 18. It goes all the way up to Z, okay? And those haven't been researched yet, so they're probably going to get bigger. But these are the tag lines for 18, and there's how I've done the numbering. I've had AZ32A and then 2A2, because 2A and 2A2 go together. Then 2A3A, and then there's 2A3B. Again, those are separate. And then 2A3C, 2A4, 2A5, and 2B. Unfortunately, because I had already divided 3Z up into like Z1s to like 26, I would have to renumber everything, and it would take me too long to do that. So I add extra letters, whatever's the next one. So again, look at the video responses or look at the index in order to figure out which one you should look at next, okay? Here's the titles. It's going to go on the tag. It's going to go actually in the actual video itself for line 18A3Z. Those ones all have to go together because they all have some sort of formula or they have something to do with the formula. So I don't want you to forget to do one because it's important, okay? So there's the title of that one. That's the next title for the next video. And this is the only time I'm going to show you these tags because I've put them on all the videos, but we don't need to go through them all because they're all the same, okay? And there's that title and that title. Again, this is going to go up on the blog with the video. So once you look at the first one, I blog. What I do with this is a whole set of a line like 18A3Z. All those videos that are A3Z and whatever numbers subsequently are all going to be blogged at the same time so that you can go from 1 to 1 to 1 to 1, okay? So there's going to be quite a few. So these are the tags of the words that are going to show up in all the videos, just so you can see what we're going to be talking about. Okay. So we had one formula come up in here and then an explanation of what the terms were, which is why I look for all that information. And this is a huge section, as you can see. And there's I've got a lot of PDFs for you, a lot of write-ups of papers of test results. So this section is going to be really good. It's not so much research of what does this word mean, what does that word mean. It's actual papers from people that are in the science industry or work in the physics at the different labs. I got Bell, I got CERN, I've got university people working on, it's all physics students or actual professors, people that are actually have their degrees and stuff. So yeah, there's a lot of them there. And we got some new stuff coming up, new inventions. I'm just going to double check there's nothing there. Okay, so that's the end of that video, and we'll go on to the next one. Oh, we're not done yet. Sorry. Okay, look, I got some nice graphs for you here. This is the lead blanket that I'm talking about for that China thing. China thing, sorry. This is a design status and development strategy of China liquid lithium lead blankets and related material technology. So I Googled it because I like pictures, right? I think it's easier to remember what something is by looking at pictures, especially if you're not familiar with physics and stuff. This is just an easier way of seeing it and understanding what we're talking about. And here's a graph of a seamless carbon steel pipes. It says operating temperature, and it says allowable stresses. So that's something you're going to need. You need to have something that does heat stress. I found some new stuff for you for steels and stuff of theories and testing results for new steels that are very high in heat resistance. So stay tuned. This is a seamless carbon steel pipe. Operating temperature and allowable stress in pipe walls for seamless carbon steel pipes. There's the grades for it. Allowable stress is seamless ferritic alloy pipes. It's from engineeringtoolbox.com. Here's the cross section of the outer. Toroidal coil, vacuum container, blanket, first wall, diverter. So it looks like. Here's a magnifying view of a diverter. Gives you an idea. It's a device to exhaust He-ash, He-E, I think that might be helium, but I'm not sure. He-ash produced by nuclear fusion from the plasma. It is dispensable for maintaining the purity of plasma and for running a nuclear fusion reactor over a long period. The ITER diverter has a cassette structure in which the target is combined and should be replaced every 3 years by remote control methods. And they use a remote control to do it. Interesting. So this is a heat load graph. It's got diverter, fast breeder reactor, light water reactor, and then boiler. The target of the diverter is subjected to particles and heat from plasma and is exposed to a thermal load of from 5 to 20 MWs, m squared. This is equivalent to the heat that would be produced if 5,000 to 20,000 home use heaters at 1 kilowatt were placed in a 1 meter square space. I don't think you'd fit that much space. The thermal load is more than 10 times that of a light water reactor. To withstand the high heat load, it is necessary to develop high heat resistant materials and high performance cooling tubes. And that's where their carbon nanotubes come into play. So you'll be learning more about carbon nanotubes as well. They showed up in line 18, but they're also in with the space elevator too. So stay tuned. Next video.